This is section 9.5, part 3. Alright, so we had just learned some identities in the prior recording, and now we're going to be using those for various problems. So let's see, if we're told that theta is in quadrant 4, find an expression for secant of theta in terms of sine of theta. Let me explain that terminology in case that's not something that you're extremely familiar with. When I write, let's say if I have 2x plus 2y equals 18. And if I'm asked to write this equation or find y in terms of x, what that means that I'm supposed to do is solve the equation for y and have an expression on the other side that has only the variable x in it. Now, of course, operations like addition, subtraction, multiplication, division, numbers, other things can be in there. But when this says find secant theta in terms of sine of theta, I want secant of theta is equal to, and what's on the other side, the only trig function that should be over there is sine of theta. Okay? So, how are those related? Well, I remember secant is reciprocal of cosine, and I know sine and cosine are related by the Pythagorean identity. So, I want to start with that. Let's start with a known truth, like sine squared theta plus cosine squared theta equals 1. And I know that I'm trying to get secant, which means it's related to cosine, so I really need to get cosine by itself. And notice that what I'm getting on the other side is an expression that's in terms of sine of theta, so I think we're on the right track. Then we'll take the square root of both sides, which will be plus or minus the square root of 1 minus sine squared theta. And then to get this to be right, I'm going to think about this quadrant 4 thing. All students take calculus. Cosine is positive in the 4th quadrant. So that means of the two possibilities, because we're in quadrant 4, cosine of theta will be a positive answer. Now, a little while ago, I mentioned a equation solving technique that's really handy at times. I'm going to take the reciprocal of both sides of this equation. So reciprocal of cosine is 1 over cosine. The reciprocal of the radical is 1 over the radical. And then using an identity that we learned earlier, the reciprocal identities, 1 over cosine theta is secant of theta. And then we should rationalize that expression. So to rationalize it, I should make sure I write it carefully. To rationalize it, I'm going to multiply it by 1 in the form of that radical over itself. One times that radical in the numerator is that radical in the numerator. That radical times itself gives me the radicand, the thing under the radical, as an answer. So that'll be 1 minus sine squared theta in the denominator. And that is our final answer. That is secant written in terms of sine of theta. All right, so let's look at another example. A downhill highway grade is modeled by the line y equals negative 0.06x. So let's graph that just so we have an idea of what we're talking about here. So I see it's in y equals mx plus b form, which is helpful because that means that my y-intercept is 0. So it goes through the origin. And the slope is negative 6/100ths. That's what negative 0.06 is as a fraction. So I could get that by going down 6 and right 100. And this is not to scale. If I drew it to scale, it would be way too big. So that right there, down 6 and over 100, is a point on that line. And so this is what that roadway looks like. Sort of. Of course, it's out of scale, so we can't say it looks exactly like that. But that's the roadway. So if we think about the triangle that we could draw here, the y is negative 6, the x is 100. Okay, that's just to give us a little perspective. And it told us that this was the part of the line in quadrant 4, which is what I assumed when I started drawing it. I probably should have read the directions to see that that's what I was supposed to do. Sorry about the dog barking. Can't be helped at this point. Maybe you can't even hear it. At least that's what I hope is going on. All right, so we're supposed to find the grade of the road. So let's do that. So the grade is that we're going down 6 feet for every 100 feet of traveling horizontally. And so that's actually an answer. We're going this much down 6 for every 100 feet, and that's a percentage. That's negative 6%. That's the grade of the road. Okay, so that kind of answered itself just when I drew the picture. That's kind of nice. B says approximate the grade resistance. Grade resistance. This is going to require a formula that you don't know, and I'm not going to have you memorize this one. So if there's a problem like this in homework or something, feel free to look up this formula because I'm not going to ask you to memorize it. Grade resistance for a 3,000-pound car. On this roadway. And interpret the result. Okay, so first of all, the grade resistance formula that I want you to know is R equals, not supposed to know, not memorize, but you need to know it for this problem, is W times the sine of theta, where W is the weight of the car. Okay, so this 3,000-pound car means that W is 3,000. Okay, so see, to know sine of theta, we're going to need to know R. So let's over here to the side calculate R using a formula from way at the beginning of this lesson. It's the square root of x squared plus y squared. So R is the square root of 10,036. That's not a perfect square, so I'm just going to leave it in that exact form. And that means that the sine of theta, which is defined as y over r, for this problem, we've allowed y to be called -6, and r is this radical that we found just now. Okay? Now, you could rationalize that, but I'm not going to ask you to, because this grade resistance, I really like to have an approximation of it, so you don't need to worry about rationalizing that. So we'll substitute in 3,000 for W, and the sine of theta is -6 over the square root of 10,036. Then substitute that into your calculator, type it all into your calculator, and report the result. And we are approximating, so use approximately equal to. Because notice the direction said approximate the grade resistance. So that means the approximately equal to is used, and we typically mean there to go to a decimal form. All right, so if you put that in your calculator, hopefully I've given you enough time to do so, you should get -170, whoops, I wrote a 9. I said 7 and wrote 9, my apologies. -179.677 pounds. And now we're supposed to interpret that. So let's see what that means. Let's see if we can understand this. On this stretch of highway, gravity would pull a 3,000-pound vehicle downhill. And by the way, the negative part of that answer is why I'm saying downhill. With a force of about 180 pounds. Now, it's okay in your answer here to round to something else other than the 3 decimal place rule that I gave you earlier, because in your work I can see your 3 decimal places. So in your final answer, if you want to round even more than that, feel free. It's fine with me. All right, so that's what that means. All right, so that ends this lesson. I will see you in class.